Hi, this is Wes Simpson, founder of LearnIPVideo.com, with another part of our presentation for NAB New York, hosted by AIMS, Alliance for IP Media Solutions. With me today is John Mailhot from Imagine Communications. And John, I'll let you introduce yourself and tell us what you're doing today at Imagine.
Oh, thanks, Wes. So I'm John Mailhot. I have about 12 hats I wear, and my day job that pays for my kids to go to college is I'm the CTO of networking and infrastructure at Imagine Communications. So I work on all the technology that makes television, and then in my other hours, I also am on the board of directors of the Video Services Forum and the Advanced Media Workflow Association, which are kind of the two key standards groups involved in the infrastructure of television and figuring out, across companies, how do we work together to make things well? And then I was recently made a fellow of the SMPTE as well. And then one of my roles in SMPTE is I'm the document editor for SMPTE 2110, which is an emerging standard for how we use IT infrastructure to do television. And that's been a very interesting ride and some of what we'll talk about today.
Yeah, that's great. That's great. So you're really getting into some interesting territory with Ultra HD. That is seems to be coming on pretty strong right now in the industry. It seems to be the fact that all these televisions going out through Amazon Prime Day, a lot of them have Ultra HD capability, and people are getting used to watching it on their over-the-top services like Netflix and of course Prime and things like that.
Oh, for
So
sure. Yeah.
it's a challenge, I think, for the broadcasters are looking to they have to compete. They've got to deliver that really cool content. So they got to produce it.
Well, sure. And it's not, there's three or four things that make it different, right? So UHD, everyone just gravitates to, oh, it's twice as many pixels. Well, it's actually four times, but we'll go there in a minute. It's 4K, right? It's really super fine grained. But the thing that makes it look fantastic isn't just that. I mean, that's sort of neat, but like if you really start looking, it's the brightness.
Mm.
If you Yeah, I replaced my own TV at home with a 4K set, and it wasn't because of the resolution, but it was just, it's so bright. You don't have to dim the lights to watch proper TV. You can really, have a tremendous viewing experience. Even on regular content, these sets do some gamma mapping and things that just makes it pop in a
Hmm.
way that's, it's pretty appealing. If you take off your engineer hat and just let yourself be entertained, it looks really good. But that's the trick in the industry, is not to get sidetracked by the numbers, which make it hard, but also to really look at how do we use this HDR, this high dynamic range that's now built into more and more of these displays, because that's something that can really be used in a creative storytelling kind of way.
Hmm. Yeah, it's more of an artistic tool than a technical tool, if you think about it.
Yeah, it's a limitation that, TV cameras that were built out of, phosphor tubes in the 40s had a certain, sort of black to white ratio. They could do like 8 stops. And then we accepted that, and that was built into the definition of television, that 100 IREs means this and 7.5 IRE meant that. And that was the definition for the next 50 years or 60 years of television.
Hmm.
Now all of a sudden, guess what? The displays are now a million times better, and so are the cameras. The cameras now have tremendous range inside them too. And what we're stuck with is all the stuff in the middle, and how do we use it? So that's been the big effort on the HDR front, frankly, has been how to take the great range that comes out of the camera and map it into the kind of 10-bit plumbing that we have everywhere, and then the TV knowing how you did that so it can undo it.
Hmm.
Um, so it's, there's all kinds of ways that the fact that the cameras can make UHD and HDR and that the displays can display it, here we are as a television industry figuring out how do we fill in the middle. Now, yeah, the OTT guys, they have it a little easier because for them, the middle is really all in their own machine room. They can make the video and send it straight to the TV.
Mm-hmm.
But if you go through the normal television infrastructure of networks and affiliates and cable head ends, every person along that chain has to do it right, or it doesn't show up at the home in UHD and HDR. It shows up in something less,
Mm-hmm.
and maybe something a lot less if you don't do it well.
Well, and the other challenge is that, like any good standard, there's some flexibility built in. You have choices, and
Yeah.
that can be a good thing, but it can also be a bad thing.
Oh, sure. And that's like the hallmark of the television industry has been, anything that we do in the television industry, it seems like we come up with a way and then we come up with another way. And then there's a third way that's better than the second way, but breaks the first way. And, it's sort of like one day someone's going to have to explain to me the history of there was D1 and D2 and D3, and there must have been a D4. There was definitely a D5. And I think I heard of a D6 once, tape format. So, they can't all have been perfect.
Right, right, right. So you had some slides you wanted to share with us?
Oh, right, right, right. I mean, I was sort of noodling on this because I talk about these topics a lot, and
Uh-huh.
I did. Funny enough, I did have a few slides fired up for this, but it's sort of a talk I've been working on in the background and how to do it, because on the infrastructure side, and like I said, my job is I'm the CTO of networking and infrastructure. The infrastructure of television, what do we have? We have miles and miles of coaxial cables, and we love them, right?
Sure.
And so everyone thinks, UHD, it's just 4 times HD, but it's not really 4 times HD. It's 4 times 1080p. It's 8 times HD. Now, okay, 8 wires, that's kind of gruesome, but 4 wires, that's plausible.
Mm-hmm.
Except if you think about most people's plants, did you really build your plant to do 1080p? Well, everyone kind of says, well, it ought to work, but you can quit pretty quickly if you try to do 1080p in your plant. Unless you really detail designed it to do 1080p, you'll start to find a couple of cable paths, coaxes in your plant that are just too long or aren't kind of good enough wire to really do it. Maybe they're wire left over from analog that you just never replaced because it was inconvenient. Patch panels that could pass HD, but maybe 3 gig, they just roll a little too hard, or
Mm-hmm.
graphic systems, router cards. You'll find all kinds of bits of your plant that unless you really did it right, you don't just turn on 1080p and it magically works. But that's okay. We know how to fix these things. Now, at least it's still on SDI, right? But anything like we're talking about with tape formats, well, it turns out in UHD, the first thing people did is they cut the picture into 4 corners, like I show here. Now,
Mm-hmm.
that'd be cool. And that seems like a good thing. And there were some switchers and things that could do UHD if you did this. Now, so that's called square division multiplexing. Now, those aren't squares, so I'm not sure quite why it's called that, but for what it's worth.
Rectangular is too big a word, I guess.
Yeah, well, and this lets you use some legacy gear to do UHD, even if the legacy gear didn't understand that it was UHD. So you could take, 4 DAs and use it this way, for example. But it's not perfect, right? There's a couple of challenges with it. I mean, this method is obvious, but it's not written down anywhere until much later. But at least it's obvious. Now, it gets dicey as soon as you go through a frame sync, because those 4 signals don't know about each other. So if you're actually doing an asynchronous handoff between 2 people, those frame syncs are going to flip at different times, and you might naively think no one's going to notice. Oh, no, that jumps across the room right into your eyeballs. If one of those frame syncs flips and is a frame later than the other 3, oh yeah, you know that.
Mm-hmm. Mm-hmm.
Okay, fine, but then what? Then, the worst problem with this, it adds a half a frame of latency every time you touch the signal. Now, is that a big deal? Well, you tell me. Before COVID, we always thought another half a frame of latency was the end of the world. Now, we're a little more tolerant now, but still, it's a challenge when going into the thing, you lose a half a frame, coming back out, you lose a half a frame too, because you have to, wait till you get the last pixel you get in this format is in the middle of the screen.
Mm-hmm.
So it's just a bit of a pain. But, there's still 4 wires, but there's nothing in each of those wires that even says it's UHD. They look like 4 random signals. You, as the engineer, have to know that it's UHD. There's one thing going for this format, though, which is that if you jack into one of those wires and look at it, you can tell which corner it is.
Right.
Now, you'll see in a minute why that's important, but that's the nice thing going for this, is that this is at least obvious, right? Now, SMPTE, of course, comes along, and I don't know, SMPTE, EBU, whoever worked on all this back in the day, came up with this 2-sample interleave methodology, where you take, 2 pixels from here and 2 pixels from there and 2 pixels from there and there, and you put the, so you divide it up in a different way, so you're taking these little tiny regions and mapping them in. Now, it's cool, and it works right, and it totally solves the latency problem. But in all these 4-wire formats, you still have the problem that how close together in timing do those 4 wires have to be? Well, it turns out the spec is 400 nanoseconds. Now, people who lived in the analog era and had to go measuring cables and cutting cables by the inch to get, phase alignment on color, they're looking at 400 nanoseconds and saying, I can do that for any day. That's easy. But it's not that easy. There's a lot of ways to add more than that amount of delay. But at least now the signals are all labeled on the wire in this method. So, if you take those 4 wires, you can, the wire, the signal says what it is. So this method's written down. Great standards work went into writing it down. The latency problem totally fixed, but there's still 4 wires. But there's a thing called the VPID, the Video Payload ID, that's buried into that SDI signal that at least tells you it's UHD and tells you which link it is and some other things. So that's good. But we traded. In the other way, you could tell which one it was because you look at the picture and it's like, yeah, that's the upper left corner. Now, if you jack into those wires, I guarantee they all look the same.
Yeah. There's no way you're going to see a 2-pixel shift.
And if you swap 2 of them, you'll stare at that picture a long time to decide that it does look funny. It's not just your eyes. But you still have like 16 combinations to go through to guess which 2 are swapped. So it takes a few minutes. It's good that they're labeled in the bits. And by the way, the asynchronous handoff, that frame sync that flips at the wrong time, it's paradoxically harder now because instead of it looking bad instantly because that one whole corner of the screen is out and you get a big line in the middle, now it just has this very subtle defect that's hard to see, but it's still wrong. Now, I mentioned this VPID, this Video Payload ID. Now, this is a thing that in SD-SDI, we didn't have this. You just figured out if it was NTSC or PAL. And in HD-SDI, we didn't really have this. But when we went to 3 gig SDI, it became important to have an identifier in the signal that told you how it was organized inside. Because in 3 gig, there was this thing, there's level A, which is like the normal way, and there was level B, which was this other way of packing 2 pictures into the same wire for various reasons, historical.
Right.
But still in use. And
of course.
So, that led people to create this payload ID. And then there was a document that generalized it back into HD and SD. And then there was a revision that changed another bit of it and added another bit. And so there have been, as I went through last night and collected some of these, and I only collected the ones that applied to UHD, by the way, there have been a whole sequence of revisions to this payload ID. And it's not that they're inconsistent with each other. They are each perfectly described. So if you have, a UHD signal on 4 wires and 2 SI, there is one exactly correct definition of payload ID. But there was also this evolution over the years, and some things got tweaked and added in the colorimetry and the transfer characteristic and all that. That means that if equipment was built before a certain time, it may not understand the current one. And plus, just because there's so many to choose from, we've run into a lot of equipment that we try to interop with that just guessed wrong or didn't understand the spec or pulled out the wrong spec. And so, foo on them for getting it wrong, but foo on the industry for having a problem, because what it means is that every time you do UHD, you have to be a little wary of, is the piece of equipment understanding its input signal correctly?
Mm-hmm.
And there's kind of three fields in here that matter a lot. They all matter. Don't let me say
Sure.
they don't matter, but they all, there's an aspect ratio field in there
Mm.
that says, 16 by 9 are unknown, except in one of the other specs, it says 16 by 9 or 4 by 3.
Hmm.
And so there's some equipment that sees the 0 and assumes 4 by 3. And then there's other equipment that, you're doing something slightly funny, so it sets it at 0. It's just, there's, sometimes a problem gets caused by this thing that was trying to help. The colorimetry field there, Rec 709, is there a color VNs packet that says, these are things that were added kind of, relatively recently. UHD TV, okay, that one is the we call it Rec 2020 color space.
Mm-hmm.
And then unknown, what are you supposed to do if you get an unknown? Like that's not as helpful as it seems to have a way to signal unknown. But
Yeah.
it gets worse, because transfer characteristic, okay, that's where your HDR is buried. So you say, okay, SDR, that means I'm not in HDR. Okay, everyone understands that. HLG, okay, it's very specifically, there's a document, an ITU's BT2100 spec defines HLG, hybrid log gamma.
Mm-hmm.
And then the same spec, the next section, defines the perceptual quantization method, PQ.
Mm-hmm.
And so those are all in common use. But what about slog3?
Right.
slog3 is also used quite a bit.
A
Makes
lot.
beautiful
Yeah.
pictures, ton of equipment in the field speaks it. So if I'm making SDI and it's in slog3, because that's what I switched on my equipment, what's it supposed to put in that field?
Mm-hmm.
Because it's not SDR, it's not HLG, and it's not PQ. So maybe that's what the 3 is for.
Mm-hmm.
Okay, but that's like, as when you're generating it, like you don't have a lot of choice. You got to put the 3 because the other choices are clearly not right. Now you're receiving a signal. If you get something that says number 3, can you assume that it's slog3? Or do you just wind up assuming that you don't know?
Mm-hmm.
And so it creates another user setting to say, should the user assume that it's slog3 if it gets a 3, or should it, it's like, it's choices that,
Yeah.
you got to make all of a sudden.
Yeah. The big problem with any choices is you have to be informed about what the implications are of your choice.
Right.
And
so
that's really hard.
yeah, and the net of this is that it's just another thing you got to watch out for. It's a little sharp edge there at the side of the desk that you just got to not clip yourself on.
Mm-hmm.
And not every piece of gear gets it right. So it's just something to watch for. But it all comes from the fact that we're sitting here arguing over 24 bits. This payload ID had 24 bits in it. And that's a pretty small scratch pad to be sketching our entire future on.
Mm.
Now, oh, by the way, this whole 4 wires thing, like that 400 nanosecond spec, that goes away in a heartbeat when you put a DA, like say you wanted to take a split off one of those 4 legs to, go into your multi-viewer or something, right? Oh, guess what? If that's a reclocking DA, then it may be longer through end to end than 400 nanoseconds. So suddenly your 4 wires are out of spec because you delayed one of them.
Mm-hmm.
You wind up buying a thing called a power divider that's sort of like a cable TV splitter, but works at 3 gig. That's a weird thing to be putting in the middle of your television plant. Now, when you have 4 wire signals going through an SDI router, can they all switch on the same vertical? Yeah, they can. And they do by and large, because back in the old days, we had analog component. And it was pretty important that those analog component signals switched on the same vertical. So
right.
As a router industry, we're kind of hip to that problem. So that one, thankfully usually works fine. But if you have frame syncs, like we talked about earlier, if they don't understand that it's a UHD signal, they have to sort of coordinate. If they're 4 separate frame syncs you pulled out of your desk drawer, guess what? They're all going to flip at different times when you got an asynchronous input. So
Right, right,
it's
right.
4 times the fun. I'm not sure that, nobody looks at the 4-wire thing and says, hey, that's yummy, I want more of that.
Mm-hmm.
So the natural reaction of the industry has been 12 gig SDI, and that gets us down to 1 wire, which is great. And it, if it was perfect, the world would use it, and the world does use it. 12 gig SDI is out there, people build things with it. If you're in a constrained space environment, like, those wonderful cabins on wheels with expanders on the side, 12 gig SDI is a great solution if you're within the cable reach of it, because it does have some significant limitations compared to what we're used to. But that's okay. I mean, within a truck, no wire is longer than 30, 40 meters. I mean, even if it goes a crazy route, the truck's only so big. Even a small studio, is where are you going to go? The chips were, expensive at first, but they've come down a lot. The transceivers and things for it are only a little bit more expensive than 3 gig ones. And any equipment that speaks 12 gig is new enough that they probably figured out and read those specs we were talking about, those VPIDs. So that all tends to be okay with 12 gig. People get this right. And because it's 1 wire, 1 signal, frame syncs and things understand it, and it's 1 signal and all those other asynchronous handoffs. So all that said, the only problems with 12 gig really that come up are the cable length, and in optics, the fact that the optics are a little bit expensive and unusual, frankly. They're not just 10 gig SFPs tweaked up. They're a little different inside because 12's not 10. It's a different, a different reclocking strategy for sure. But we see a lot of 12 gig. Works great, especially, short reach, hooking stuff together within a rack. Oh, it's fantastic. Now, that's fine. So people tag me as the IP guy, and so everyone's expecting, what am I saying about IP? Well, in fact, we did do early on. I mean, as soon as 12, UHD existed, people started trying to do it in IP. And so the first natural reaction was, well, just take those 4 1080p's, map them into 2022.6, because back in the day, we used this thing called 2022.6, which was just SDI over IP.
Right. So
now you've got UHD cut in 4, wrapped in SDI, wrapped in IP. There's a variety of problems with that approach. Not the least of which is that you've now duplicated all the headaches of SDI 4-wire and the challenges of IP and SDI and IP. So you've kind of accumulated those problems. And how are you going to switch that? Like in the network or in a receiver, you're now saying, I'm going to join 4 new streams and swap over from the 4 old streams. And it's,
right.
SDI routers understood how to do 4 things at the same time because that was a common problem in a previous generation of routers. The network guys, there's no use case in IP networking that says to do 2 things at the same time.
Right, right.
It's just that's not a phenomena that has existed previously. So very, very hard to do 4 streams UHD and get the normal television things that we've expected. The best way really is you figure out, how do we make UHD 1 package inside the network? And this VPID thing we were talking about, that little 24-bit universe, it's not expressive enough, right? We need a home that's going to work for the next 50 years and have a path to signal, S-log3 and all the other colorimetries and other transfer HDR kind of systems that are going to come along. And by the way, there's a whole community of users outside of television that also want to use IP to transmit visual information. And we got to stop being parochial about television.
Right.
So that's what led us to make SMPTE 2110, is really this whole set of needs. So for UHD 2110, it's big enough, right? 2110 can go up to 32K by 32K pictures. And that's big enough, right? 4K, 8K, those are the easy ones.
Yep.
And, is it a lot of bits? Yeah, it's a lot of bits. It's just under 10 gigabits for 50 hertz. but this NAB New York, so we got to be in 5994, so it's 11.2. Okay, and that's not peanuts, but it's it's less than half a 25, and it's
Yeah.
you get 8 of them in 100 gigs, so that's not bad. There's also the compressed standard 211022, where you'd take something like JPEG XS, code up the video, maybe it's 1.5 or 2 gigabits per UHD, and that's an interesting trade-off. People say, oh, I can save bandwidth now, but I have to put a codec on both ends. So you can get a spreadsheet and do the math and figure out if that which of those makes sense for any given application, and they both have a place. I'm not picking a favorite on that.
Mm-hmm.
But the beauty is it switches and routes like one thing in the network. It's one signal, goes through the network. And funny enough, the biggest achievement in my view of 2110 isn't about the bits. It's about the signaling. That if you look here, we created a whole lexicon in 2110 of how to describe the signal. And it's extensible, right? So you say the sampling is this, and there's a whole list here of samplings, right? Or the colorimetry is this, and there's these keywords that point to these different ITU standards.
Mm-hmm.
So, and there was a tremendous participation because in SMPTE we have people from film and post and all the other disciplines. They all turned up to the meetings, and they, Jim Houston was, he did a tremendous job of making us go through and really correctly document all the different ways that people make video besides just the way we always do it in television.
Mm-hmm.
So the result of that contribution and all those contributions from the Hollywood community and the film community in large was that we made a system that describes more than just television. It describes all the other ways that people use video, and it's extensible. So as we go into more multimedia areas or the AIMS IPMX work or so forth, we now have a language that we can extend to add other color spaces or other use cases that's going to work with things we already have. So that really makes this a standard that can grow to where we're going, even though we don't know where we're going exactly.
Mm-hmm. Mm-hmm.
So it's been an interesting ride, but I'm really glad that we wound up with a system that can do UHD and can do it well and can do it in all the ways that it's going to evolve. Because frankly, UHD and HDR are going to evolve and change a little bit as we produce more and more content. We'll discover, that there's a best way. And every year there'll be a best way.
And I think that the door is still open for innovation. Some non-rectangular video formats.
Sure.
There's also going to be some really interesting things with maybe additional primary colors.
Mm-hmm.
And
yeah, I mean, every display, the vast bulk of displays anyway that people are watching television on are not 16:9, and they're not the primaries that we're engineering for right now.
Right.
So, you can match what the consuming device is, or you can convert along the way, but those are kind of your choices.
Yep. And I think that, I really agree with you. I think that this is a robust thing. And the other thing about it is that it's very, if you will, web friendly. We're talking about, ASCII text strings here. It's not bits that are buried inside of some sort of 12 gigabit per second signal. It's a text file. You can read it yourself. You can parse it. It's good.
It's honestly, it's engineer friendly. If you're trying to debug your system and you want to know what's on the wire, reading the VPID on an SDI cable involves having like a $10,000 piece of test equipment that you're going to plug the signal into just to get those bits out.
Yep.
Whereas here, you fire up your web browser, point it at the right URL, and it tells you the signal is this.
Yep.
It's pretty handy.
Yeah. No, this is good. John, this has been quite a presentation. I really appreciate it. Thanks for stimulating some new thinking, I think, within the industry and certainly within my brain. But I think that as we keep moving forward, we're going to have to keep adding some flexibility to this system. But at least we don't have to go back and rip up everything that came before and redo it.
Oh, that's for sure. And the best part, as we've moved from, HD SDI to 3 gig SDI to 12 gig SDI, I mean, the physical layer changed, the
Right.
wires changed, the jack fields changed. I mean, it was quite painful. But the IT industry, by having a separation layer and saying, look, you make IP packets, Ethernet, they get delivered. There's a separation layer there, right?
Yep.
So the fact that during the time we've worked on this, that part of the equation has gone from 10 gig to 25 gig to 40 gig to 50 gig to 100 gig to now 400 gig.
Yep.
And nothing about these standards is affected by any of that.
Right. Right.
That's huge, right?
Yep. Yep. Yeah, I think I'm pretty optimistic. I mean, it'll be interesting to see which new things get added to the Ames roadmap over the next 5 years or so. But there's going to be some new things. But the good news is that we don't have to go back and redraw the earlier parts of the roadmap. We can still use those. Now all we got to do is figure out how to do standard def, and we're home free.
It's surprising how much 525 and 625 video is still made
Oh, there's a
all over
lot
the
of it.
world,
Yep.
and not just in other parts of the world. I mean, in the U.S., there's
Yep.
still a fair bit too.
Yep. So we'll have that to play with. But well, thank you very much for your time. This has been very informative, and these will all be part of the NAB New York presentation. So thank you very much.
Thank you for asking.